Hey there, and welcome. Today we are diving into two chemical families that you run into literally every day, acids and bases. Think about the sharp taste of a lemon, or even the slippery feel of soap. That's them. But what's really going on at a chemical level? Let's get into it.
So when you get right down to it, what is the real difference between an acid and a base? Well, it all boils down to one simple, really elegant idea. And over the next few minutes, we're going to peel back the layers and see exactly what that is.
All right, here's our game plan. We'll start by figuring out what makes an acid and a base a base. Then we'll tackle the super important difference between strong and weak. And finally, we'll see how all of that neatly unlocks the whole concept of electrolytes. So let's jump in.
Chemists just love to sort things into categories. And acids and bases, they're two of the biggest, most important families out there. You can almost think of them as having their own distinct personalities, which lets us predict how they're going to behave.
First up, the acids. You've heard the term before, right? Like battery acid or the acid in your stomach. But what does that word actually mean from a chemistry standpoint? What makes something an acid?
Okay, so take a look at this list. You see some real heavy hitters here, like hydrochloric acid. And notice it's labeled strong. But then you see a whole bunch of others, like carbonic acid. That's the stuff in your soda. And they're all labeled weak. So what's that all about? That one little word, strong versus weak, is actually the key to this whole thing.
And here it is. Here's the secret. An acid is an acid because it releases hydrogen ions, those little H+ particles. Now, a strong acid, it's an all-or-nothing kind of chemical. The moment it hits water, it ionizes completely. And that just means every single molecule splits apart and floods the water with those H+ ions.
Okay, so that's one side of the coin. Now, let's meet the chemical opposites of acids. Let's talk about the bases. Now, looking at this chart, a couple of things probably jump out at you. First, just look at those formulas. Almost all of them end in OH. That's a pretty big clue. And second, notice that every single one on this list is classified as strong.
And there's the other piece of the puzzle. Where acids give off H+ ions, bases give off OH- ions, which are called hydroxide ions. So that OH we just saw in the formulas? Yeah, that was no coincidence. And just like their strong acid counterparts, strong bases dissociate completely, releasing a ton of those hydroxide ions into the water.
So we've been throwing around these words, strong and weak, for both acids and bases. But what does that really mean when you zoom in on the molecules? This right here is the concept that ties everything together. And you know what? It's way simpler than it sounds. Now, this is super important. In chemistry, strength has nothing to do with how dangerous or corrosive something is. Nope. It's about one thing and one thing only, how completely it splits apart when it's in water. So here's the formal term for it: complete dissociation. When something is strong, whether it's an acid or a base, it means that when it hits the water, every single molecule breaks apart. 100%, no holding back.
Let's just look at them side by side. See? The behavior is exactly the same. Strong means they both break apart 100% of the time. The only difference is what they release. Strong acids give you that high concentration of H+ ions, while strong bases give you a high concentration of OH- ions.
So, if strong means 100% commitment to breaking up, you can probably guess what weak means, right? Weak acids and bases, well, they're just not that into it. They're much more reluctant. When you put them in water, most of their molecules just stay together, and only a few of them actually split apart to release their ions. So, why are we so obsessed with whether these things break apart or not? Why does it matter? Well, it's because this one idea, dissociation, is the key that unlocks another huge concept in chemistry: electrolytes. Okay, what's an electrolyte? It's just any substance that forms ions when you dissolve it in water. Now, hold on a second. H+ and OH-, those are ions. This means every single acid and base we've been talking about is, by its very definition, an electrolyte.
And this is how it all clicks into place. It's a simple three-step process. First, you figure out if you're dealing with an acid or a base. Second, you classify its strength. Is it strong or weak? And that's it. Because the connection is direct. A strong acid or base is a strong electrolyte. A weak acid or base is a weak electrolyte. It's that simple.
So let's just lay it all out. Strong electrolytes, which are our strong acids and bases, release a huge flood of ions. And those ions can conduct a lot of electricity. Weak electrolytes, our weak acids and bases, only release a trickle of ions, so they only conduct a little bit of electricity. And then you have non-electrolytes, which make no ions at all. See? It all fits together perfectly. Okay, let's end with a bit of a cliffhanger. We know that strong acids are basically programmed to dump all of their H+ ions into a solution, and we know strong bases are programmed to dump all of their OH- ions. They're perfect chemical opposites, right? So, what do you think happens when you put these two all-or-nothing chemicals together in the same container? Something to chew on. Until next time.